So I've been making a ton of these little headband pieces lately. It's a strip of polycarbonate with a little rubber band around the end, and you can wear it over your forehead pretty comfortably. It's actually part of a little face shield assembly. And what we've been doing so far, if I show you, is using some of our sheet metal tools to make these pieces. They all start out as this pretty unwieldy 4-foot long sheet of polycarbonate. It's a little awkward to move it around and manipulate. You can imagine I'm standing here all day shearing little strips of polycarbonate to make these headbands, and then after that I'd gather them up and walk them over to our tiny little sheet metal brake. And I have to stand here and one at a time open the brake, eyeball the strip in, pull it in, flip it around, pull it another, grab another piece. This tiny little bend is exhausting. It's mentally exhausting, it's physically exhausting. I swear, if the bender was maybe 2 inches taller, I'd be pretty comfortable using it. But I got tired of it pretty quick when we're making these in the hundreds, quickly approaching 1,000 or so, and decided maybe there's a better way. Maybe there's a different approach to this. And having access to all of these wonderful pieces of equipment, I decided to walk over to our tiny little automated line and see what I could come up with. I wanted to do this as quick and dirty as I possibly could. No sense spending all the time on it if it wasn't going to work. So I came over to the robots, the milling machines, and I pulled one of the vices, one of the little pneumatic vices out of the milling machine. And I wanted to see, could I bend this plastic using the vise? So what I did is grab a pair of soft jaws, and one of the teeth from our sheet metal brake, and I just bolted it straight to the soft jaw. Plenty of slop in there, that way I could tighten it up with this back edge nice and snug. I grabbed that and a couple of parallels and a V-block. Because over on the sheet metal brake, we're basically just stuffing a piece of plastic into a little V-block with this wedge. It surely is not that much different. I tried my best to line everything up and then actuated it. Lo and behold, no. It didn't even remotely work. Well, I mean, it bent the plastic. That worked well enough, but that is not the angle we're looking for. We're looking for a much more acute angle. So I said, what's wrong here? And these angles don't match, not even remotely close, and the plastic's going to spring back after I try to bend it that sharp. So I grabbed a chunk of plastic and I copied the angle of the wedge onto this little piece of plastic to see if maybe I get a little bit of a better result. Stuff the little piece of plastic in. Cycled the vise, and surprise, that's actually quite good. That's almost acceptable. The only thing that I needed to figure out after realizing, okay, this has some potential, is how do I make the little dog ear the correct length every single time? So I did some thinking. I figured, how do I have this set up right now? How can I get this into the computer so I can make a quick CAD model and then machine a part that actually mimics the behavior of this block? I pulled some tricks. I knew that this was a tiny little 45-degree wedge. I know the dimensions of this soft draw because I can just pull them off with a pair of calipers. And then a fun little trick that I like to do is I grab the edge of a Sharpie and just carefully drag it across the front edge of this wedge and suck of ice. And that left me an awesome little imprint of sort of where this geometry fell on the part. There's a couple extra tolerances that go in there, like can't make this the bottom half of the wedge. This brown line doesn't match up with the bottom half of this because there's material in there. There's stuff that is definitely in that way. A little bit more math, and probably like 15 minutes at the computer, and I came up with this little guy. It's all the same geometry that you see on the plastic block that I just broke down on the band now. But in addition to that, it's got this lip right here. It's got this tiny little lip, and if I put the plastic piece there every single time, it is going to give me a perfect little bend. I'm of the mindset that if you can't figure out how to do it by hand, make it as dead simple as you can, there's no chance that you are going to be able to make the robot do it for you. But this was promising. This was extremely promising. I was really pleased at this point. Consistency is great, length is great, the angle is perfect. So I decided, okay, we'll spend a little bit of time messing with the robot and see what we're able to accomplish. What I ended up doing is building this little rack right here that holds all these polycarbonate strips. Diminishing returns. It would have been cool to sort of dispense a piece by piece, a piece of polycarbonate to the robot to bend these pieces, but there wasn't time, and honestly the return on that is probably not worth it in the long run. So I just laid them out in a nice little stack and said, well, 10's enough to make it any one time. Any more than that, and honestly, the robot stands a chance of messing up. If I let it run for 20, 30 parts and I don't catch it messing something up, I'd be really disappointed to waste that much plastic. I got to the point of programming it. What it does is bring the robot all the way down to this little base station. The nice thing about the Universals is they have a really slick palletizing feature that makes it pretty easy to iterate over the 10 different stations here. Getting it into the general vicinity of the vise, I should watch my fingers, that was easy enough. In fact, it was surprisingly easy. The thing that I spent all the time with was figuring out how to actually get it to do this motion. It's really, really annoying, but as you can tell, 6-axis robot, and when it's doing that tiny little bending action, 4 of the 6 joints are in line with each other, and the other 2, they don't really do much for me. They sort of just throw everything out a square. We got 1, 2, 3, 4 joints in a line. This one's not helping me, and the base isn't. So I had to bring the linear slide into the equation. Try to figure out, okay, is there a position on the linear slide that brings this piece of plastic in just the right design? Found it, fiddled with it, cleaned it up a little bit more, and I'm actually getting astonishingly good results out of this. Now, don't take this for granted. Don't take it for granted that this program just worked out of the get-go. This is actually my 4th iteration. I'm doing everything from removing extra waypoints to speeding up joint accelerations, making the robot move a little faster. It's an awesome thought experiment to figure out, hey, well, if I move the robot too fast or accelerate too quickly, I'm going to have a ton of vibration at the end of this long strip of plastic. Or if I'm not consistent with how I pick it up, maybe it's going to pick it up at a funny angle. But I was super, super pleased when I got it dialed in. What I found, in 300 parts I ended up making, like two misstrikes, just 2. Everything else seemed to work really just fine. So I was really pleased with this and figured I wanted to share. It's a great thing to let run in the background while shearing up some more plastic or counting out rubber bands to make those headbands. Anything that the robot can do to save my arm, save my back from standing over that sheet metal brake all day, I'll let it run. Even if it means I have to come over here every 5 minutes or so and feed it a little bit more material.